What do most IT teams overlook when they claim to have full stack observability, and why is legacy network observability outdated these days?
Typically, the term you hear often used nowadays is MELT, which is metrics, events, logs, and traces. And when you think about the things that are being monitored or observed with that information, we're typically talking about servers and applications. Organizations need to understand how their compute infrastructure and their applications running on that are functioning and performing. However, all of those servers are connected to networks, and all of those applications communicate over the networks, and users consume those services, again, over the network. So what we believe and what we see among our growing customer base is that there's a real gap in the full stack story that has been told in the market for the last 10 years, and that is the network.
Bad guys take advantage of these silos and recognize that there are many layers that they can exploit in the network that other folks in IT don't even understand.
It's helpful to first just level set on what we really do here at ElastiFlow, which is we focus on network connectivity related information. What we see in a lot of organizations is a lot of work done to protect the perimeter of the network. Once those bad actors manage to break past the perimeter, or, and this is typically the bigger danger, an internal actor is attempting to do something, then they lack that visibility. Well, the great thing about the data that we collect is going to be, your switches, firewalls, even in the cloud, like VPC flow logs is a term. They all emit these, or enterprise class gear can emit these records that provide this information.
Hello and welcome to Tech Transformed, your go-to podcast source for emerging technologies and how they're shaping the future of business. I'm Dana Gardner, Principal Analyst at Interabor Solutions, with more than 25 years of experience in IT analysis and enterprise IT podcasting, and I'll be your host for this episode. Stay with us now as we welcome Rob Cowart, Co-Founder and CEO of ElastiFlow, a company that delivers highly scalable and performant network observability and security analytics solutions. Today, we'll explore why traditional observability tools built around metrics, events, logs, and traces leave a critical blind spot, the network stack. And we'll learn how application-focused solutions that prioritize connectivity and user experience, not just device monitoring, are required for full stack observability. IT teams at best find root causes more quickly using true comprehensive observability, develop a gift that keeps giving. So let's get into it. Welcome, Rob.
Hey, Dana. Thanks. Glad to be here.
Glad to have you with us. Let's start at the top. What do most IT teams overlook when they claim to have full stack observability, and why is legacy network observability outdated these days?
Well, you hinted at some of it right there in your introduction. There are a number of vendors out there that like to talk about full stack observability, and typically the term you hear often used nowadays is MELT, which is metrics, events, logs, and traces. And when you think about the things that are being monitored or observed with that information, we're typically talking about servers and applications. And there's nothing wrong with that. I mean, organizations need to understand how their compute infrastructure and their applications running on that are functioning and performing. However, all of those servers are connected to networks, and all of those applications communicate over the networks, and users consume those services, again, over the network. So what we believe and what we see among our growing customer base is that there's a real gap in the full stack story that has been told in the market for the last 10 years, and that is the network. And in particular, what we like to think of as network connectivity. So not just the state of network devices, but the actual way that the network is being used to deliver the services and applications that users need, or even applications need, communicating with each other.
All right, well, let's try to better define this network-shaped blind spot. What does it look like in practice, and why is it an ongoing problem for identifying significant performance and security issues?
Let's take, for example, I have an application that is deployed, and that application has a need to persist data to a database, for example. You might, in a traditional application performance management, APM type solution, you might see that solution will tell you, well, the call to persist data to the database was slow. And by the way, that can have a real impact. That could impact the user's perception of that application that they're using. They want it to be snappy. They want it to perform well. It could also create other types of issues. And so it's important to understand, why is the database slow? What is going to be missing a lot of times, though, was the database slow? Or was the network slow between the database? For example, maybe there's an issue that occurs on the network and that traffic needs to be rerouted a different path. And that path has additional hops, which adds additional latency. And that's really why the database is slow. Or even a little bit more nuanced, the connection to the database is fine, but the database is using network attached storage. And perhaps it's the network between the database and the storage array itself that is having issues, and thus, again, is why the persist to database function call was slow. And so if you don't have a view of the network itself, then you don't have the full picture of what's actually causing problems. And oftentimes what this ends up causing is very long troubleshooting cycles, very pretty much a lot of load on that operations team that they spend just more or less poking in the dark to try to find out what the problem might be before someone finally says, let's ask the network team. But then it's even the question, does the network team have the tools they need to be able to diagnose that as well?
Yeah, and it doesn't help, of course, that there are separate teams. And so you have silos of responsibility and finger pointing that can happen, right?
Oh, absolutely. I mean, I think we've been seeing this for years. And in fact, I think most of the world experienced this just in the last few weeks when with the issue that was at AWS, which was DNS related issues. And so the first thing that starts happening is finger pointing. It's right after the old adage that it's always DNS is it's always the network, right? And so that's a big problem. What we actually see is, it's interesting to see the journey that we see a lot of organizations on. There are certainly many of them that they're still trying to hold on to their kingdoms in these silos. But yet we do see an increasing number of organizations where, especially because leadership has business outcomes they need to drive, that are saying, we need our teams to be able to better work together to resolve problems and provide the services that our users and customers need. And if they're going to do that, they need common data, and ideally common data and common tools. And that's something that we're working hard at ElastiFlow to enable.
And in security in particular, the bad guys take advantage of these silos and recognize that there are many layers that they can exploit in the network that the other folks in IT don't even understand. So how is security, and specifically something that we need to consider when looking at the holistic, full comprehensive observability?
So a few minutes ago, I used the phrase, how the network is being used. We talk about security, then we're saying, how's the network being used or abused, as is the case in a lot of security incidences. So perhaps it's helpful to first just level set on what we really do here at ElastiFlow, which is we focus on network connectivity related information. That means essentially what's talking to what, and what are some of the attributes of those conversations. And when you know that, yes, there's a lot of performance availability type use cases that NetOps, DevOps teams care about. However, that data can also be really valuable to the security teams. What we see in a lot of organizations is a lot of work done to protect the perimeter of the network. However, once those bad actors manage to break past the perimeter, or, and this is typically the bigger danger, an internal actor is attempting to do something, then they lack that visibility. Well, the great thing about the data that we collect is going to be, your switches, firewalls, even in the cloud, like VPC flow logs is a term. They all emit these, or enterprise class gear can emit these records that provide this information. What this really provides you on the security side is we like to think of it as a motion detector inside the perimeter. because when we see the east-west traffic, north-south traffic, there's a lot of things that we can thus identify as being anomalous because we have used various methods to learn what's normal behavior, and then we can flag those anomalies. One of the things that we see that's becoming particularly interesting as well is that a bad actor might actually infiltrate an organization, but they don't actually attack that organization that they've infiltrated. What they do is they use their infrastructure as a launching point to attack other things. So by being able to have that as, again, motion detector of what's going on in the network, it's quite interesting to oftentimes what you see is outbound attacks where it's just those bad actors attempting to cover their tracks as they attack additional infrastructure. And those are things that the data that we focus on can help you detect.
Yeah, and the irony is that the data is there, east, west, north, south. You just have to get it and put it in a way that people can consume and understand. So you've said that network flow data that we're discussing is the fifth pillar of observability. So how does that include network data alongside Melt, and how do you change the teams to find and fix problems, given that we've had this sort of bifurcated approach to oversight and remediation?
What we've been spending a lot of time on in multiple phases the last couple of years, and are also launching a new solution in this quarter to help achieve, is adding what we talk about as application context. So that starts out by first just being able to say, are the what is, not just that this is a flow, some network traffic that is for HTTP, some particular IP address, like web traffic. Nowadays, almost everything is web traffic. So it's not enough to say it's web traffic, but rather to actually be able to identify a lot of those applications. Now, there are network equipment out there that provides various capabilities for doing that. Cisco has nbar 2, Fortinet has a similar capability. There are a number of them that do, but it's not universal. And it's still the smaller percentage overall. So what we also have is various techniques ourselves that, one, can add some of the common application context, even if your network equipment doesn't support it. But also, we allow you to also explain to us in various attributes about your internal applications, because that's kind of a bit of a hole that a lot of typical solutions have, is they might know the difference between what does it look like when you're talking to ServiceNow versus what does it look like when you're talking to Salesforce? But what they don't know is, what does it look like with this internal built application? We see this a lot in finance, for example. I mean, there's a lot of internal built applications. And so there's actually a really large bank here in North America that has, that uses ElastiFlow, and they talk about, because it allows them to understand their network traffic in the context of their internal proprietary applications that they built. And that's important, again, security use cases, who's accessing applications that they shouldn't be, because it's just so much more powerful to say something like, if you're a business, like, why is someone in my warehouse accessing my accounting system? It's a valid question. Instead of just saying, why is IP address 1234 accessing 5678 over HTTP?
And it sounds like you can be proactive that way rather than wait for the damage to be done. You can get out in front of it.
Oh, yeah, absolutely.
Do you have any other examples of where the comprehensive observability, including the whole network, has made a difference? How is the rubber hitting the road when it comes to these solutions? There's
a lot of different things in that regard. One of our earlier customers, they are in the, I'll call it the hospitality space. And they have a lot of internal applications that they developed to support their business. This one was a little interesting because it was more about the network team was kind of tired of being asked. Application developers, if something's not working right, they oftentimes have questions like, is my request not making it to the server, or is the response not making it back? And, they could go ask the network team, and if they have tools like ElastiFlow, they could answer that question. They actually brought ElastiFlow in to give that capability to the application teams. And so they can then go in and answer those types of questions for themselves, right?
Yeah, so that's shifting left, allowing the developers to get the access way ahead. Again, being proactive rather than waiting for things to break. That's pretty important.
And this is the one thing where we believe that there is a shift that has already begun, is going to continue overall in the market, and where we haven't seen any real innovation from what I would call the legacy network observability vendors. So because we keep seeing that pattern of empowering the DevOps, the app developer teams, because again, they want to deliver services, applications to the users, and the rest of the business. And so as it becomes more and more clear the importance of network connectivity in that whole problem space, the question is, how do we more natively get those capabilities into the hands of those application engineers, DevOps teams, SRE teams? And the way you got to do that is meet them where they live their lives. And they use completely different platforms, completely different technologies than typically the network operations team is going to be. Historically, you might be doing device state monitoring with things like a SolarWinds or a PRTG or those type of solutions, where the application team has been using APM tools like a Dynatrace or a New Relic. Increasingly, what we see, and we really think is winning the game in this regard, open telemetry. But what hasn't happened is bringing network into those spaces. And that's something that this newest solution we're bringing out will do. It is basically a eBPF-based agent. It can be deployed really on any Linux servers or infrastructure that supports eBPF. In particular, though, has additional features around Kubernetes environments, which we see really accelerated deployment of Kubernetes, whether that's in the cloud or on-prem. It can observe all that network traffic in a very, we'll call it CNI. For those that don't know, that's kind of the network overlay layer of Kubernetes. So in a CNI agnostic way, and report that as flow records. But it's not doing so in the traditional way of using technologies like IPFix, SFlow, and NetFlow. Those are things you typically hear in this space. Rather, it's doing it as an open telemetry trace. So for those that may be listening and aren't aware, an application trace is something that would monitor the different function calls that an application is making. So like make a call to this web server, make another call to the web server, take that data, persist it to the database, et cetera, et cetera. And a lot of those elements of an application trace are related to network connections, related to sessions. However, there's no visibility in the tools that these application DevOps teams live in to see that. Well, we are emitting these records and this is the first time that we're aware of anyway, that anyone's even tried this, emitting these records as trace, as part of a trace, so that you can, in the tool where you already live as an application engineer or DevOps person, you can see right alongside that HTTP call the network session that was related to that call, the latency of the network connection, and any other attributes. So being able to just directly correlate network traffic to application activity and give it to you in a platform you're already familiar with.
Now, you mentioned open telemetry. It has been gaining a lot of traction. Where do you see that it's been a strong force in bringing about full observability, and what else needs to happen in order for it perhaps to reach its potential?
So open telemetry really started a little bit more focused around application traces, and it has grown to support more general metrics and logs. That's what you hear a lot about. The idea of events are things that can really be kind of attached to the other data types. Even on our flow stuff, we will attach things such as, I try to reach out to a server. It's not listening actively at the moment. You're going to typically get what's called an ICMP message, get a message back that says, oh no, there was nothing listening there. Well, that might be an event that we would then add to that, right? Or TCP protocol has issues with congestion. That could be an event we add to that. So it's kind of evolved in that way. The network piece has been the missing piece. We asked ourselves a lot the question of those other things, metrics, logs, and traces, they're called signals. We had asked ourselves, does it make sense to kind of submit to OpenTelemetry doing a flow signal, but then we realize, no, the real power is doing it as traces. So bringing that network part in, I think that's one big piece of it. Then I think over time, what we're going to have to see in the OpenTelemetry world to continue adoption is, just continual build out of capabilities then that better correlates and analyzes that data. The great thing is OpenTelemetry provides more standard schemas. So the interoperability of data is much easier than it used to be. What needs to happen now over the top is bringing in this final piece of network, because that can help you reveal relationships between some of those attributes that wouldn't otherwise be obvious, and then carry on from there with additional analytic capabilities and proactive diagnostic.
Okay, so for those architects and decision makers that are working across people, process, and technology for fuller and comprehensive observability, what would be one important and early change that you would recommend as they try to seek more confidence in finding root causes and remediation?
Boy, I got to think about that question a little bit. One change I think they should make. Look, I think the most important shift that organizations in general need to make is, it is not enough just to say, like, is the switch up or down? Is this server have high CPU or not? What ultimately matters is, what is the experience of using that resource? And I intentionally don't say user experience, because increasingly applications talk to applications, right? So from one perspective, an application is also experiencing the other application, right? But usage experience is a key thing, because that's the ultimate outcome that the organization is going to be trying to deliver. And then once you understand the experience, it's then being able to correlate what else may be going onto that. Because the reality is, I might have a switch that's having an issue, or a power supply that's died, or a fan that's not working so great at the moment. And traditional tools have focused on those things. But most infrastructure nowadays is built with plenty of redundancy and various other, I'll call them, for lack of a better word, self-healing characteristics. And as long as the experience is being provided, you can prioritize the way you address those things a little bit differently, right?
All right. As we wrap up, thinking about a more granular look rather than red light, green light types of thinking, you mentioned the mindset of looking at the experience and then making that your North Star and perhaps reverse engineering from there. But what is it about ElastiFlow that's creating perhaps a whole greater than the sum of the parts? And specifically, how does that future-proof? By bringing more insight into the network, how are we going to allow people to do even more and better remediation and root cause analysis in the future?
Again, I come back to this. You have to have full stack visibility, and the part that's missing is the network. However, it doesn't help to take a legacy network tool and have it off on the side in a way that's not integrated into the organizations that need that information to help them improve things. What I think ultimately we are going to need to see is a coming together of a lot of these teams. I guess you could think of it like a Venn diagram, if you will, and that you have the DevOps parts of the organization whose infrastructure connects and uses the network. You have the NetOps team who's responsible for providing that, and you have the security team who's responsible for ensuring that the things that are using it are not abused. And so in the middle of that Venn diagram, though, is the network. You could even say it's the pivot point. And that's really the goal that we have as an organization, to help you understand your network connectivity in the context of the way that you're using it, which users, applications, et cetera, and ensuring that it's secure. So if you need to pivot, for example, I have a vulnerability, which applications are affected? That's revealed to me by the network traffic that is affected by that particular. So it really gives us a pivot point between all those different silos and domains. And if we can do our job and execute our vision the way that that we are working towards now, I think we're going to do a lot to facilitate those teams coming together, that the center part of that Venn diagram is a lot bigger, right?
Yeah. Seems like now's the time to get end-to-end and comprehensive observability. The case is pretty compelling, and the technologies are now available to do it. So thank you so much to Robert Cowart, the co-founder and CEO of ElastiFlow, for joining us today. We appreciate your sharing your thoughts, Rob. Appreciate it.
Thank you, Dana. I appreciate the time.
Also, a big thank you to everyone listening. We hope you took away a lot from today's podcast. For further information on what we've covered, please head over to elastiflow.com. If you enjoyed this episode, we'll be back next week with another discussion in our Tech Transform podcast series. Until then, make sure you subscribe to this podcast on all the major platforms and follow the conversation on our social channels at EM360Tech on X and LinkedIn. For more great daily content, head over to em360tech.com. Thanks again, and bye for now.